Let's begin by finding the area of triangle ABC. First, draw a line from B to AC and calculate the height BD using sine of 50 degrees, which is BD over 10. This gives a height of 7.66 centimeters. Now, use the formula area equals 1/2 times base times height, resulting in 46 centimeters squared. For our second example, we find the area of triangle PQR. Draw a line from P to QR and calculate the height PS using sine of 40 degrees, which is PS over 12. This yields a height of 7.71 centimeters. Apply the area formula. Area equals 1/2 times base times height, giving 77.1 centimeters squared. The learning intention for this part of the video is to explain how to use the area formula for any triangle. The success criteria include knowing the formula and using it to find the area of any triangle when given two side lengths and the angle in between. We are now looking at the general formula for the area of any triangle. Starting with the basic area formula, we can use trigonometry to express the height in terms of sine, leading to the generalized area formula. Area equals 1/2 times B times C times C times sine of A. A key feature of finding the area of any triangle is that you need two sides and the angle in between, often remembered as SAS. Depending on which angle is known, the area formula has three versions: 1/2 BC sine A, 1/2 of C sine B, or 1/2 of B sine C. Example 1. Find the area of this triangle. We will use the formula area equals 1/2 of B sine C, with C being the included angle. Substitute the values. Area equals 1/2 times 20 times 25 times sine of 30 degrees, which simplifies to 125 centimeters squared. Example 2. Find the area of this triangle. We use the formula area equals 1/2 DF sine E, as E is the included angle. Substituting the values. Area equals 1/2 times 8 times 10 times sine of 60 degrees, which results in 34.64 centimeters squared. Now let's practice calculating the areas of the triangles below. Remember to use the side angle side or SAS rule. For the first triangle, the area is 36.9 centimeters squared. For the second triangle, the area is 16.7 meters squared. This section introduces the sine rule. The learning intention is to show how to use the sine rule to solve real-life problems involving finding the length of a side of a triangle. The success criteria is knowing how to use the sine rule to solve these problems. The sine rule works for any triangle, provided we have enough information. The formula is A over sine A equals B over sine B equals C over sine C. The lowercase letters represent the side lengths, and the uppercase letters represent the opposite angles. The sine rule can be derived by considering a general triangle ABC and finding expressions for the perpendicular height CP. This derivation shows that the ratios of a side to the sine of its opposite angle are equal, leading to the two equivalent forms of the sine rule. Example 1. Find the length of side A in this triangle. Match up corresponding sides and angles. A over sine 34 degrees equals 10 over sine 41 degrees. Rearrange and solve for A, giving A equals 11.74 meters. Example 2. Find the length of side D in this triangle. Match up the corresponding sides and angles. D over sine 133 degrees equals 10 over sine 37 degrees. Rearrange and solve for D, which equals 12.14 meters. Here are two triangles to practice finding the unknown side using the sine rule. For triangle 1, the unknown side A is 6.7 centimeters. For triangle 2, the unknown side B is 21.8 millimeters. We now transition to using the sine rule to find an angle. The learning intention is to show how to use the sine rule to solve problems involving finding an angle of a triangle. The success criteria is knowing how to use the sine rule to solve problems involving angles. Example 1. Find angle A. Match up corresponding sides and angles. 45 over sine A equals 38 over sine 23 degrees. Rearrange and solve for sine A, then use inverse sine to find A, which is 27.6 degrees. Example 2. Find angle X. Match up corresponding sides and angles. 38 over sine X equals 75 over sine 143 degrees. Rearrange and solve for sine X, then use inverse sine to find X, which is 17.8 degrees. Here are two examples for practice. Calculate the unknown angle in each triangle using the sine rule. For the first triangle, angle A is 37.2 degrees. For the second triangle, angle B is 16 degrees.